In the last lecture, we have seen about the logical statement and which are the logical statements that we have seen in the last lecture. So we have focused here interrogative, exclamatory, imperative and open sentences are not logical statements. So we have taken the examples of each and every type, but now again we refer them. So we take certain examples for this logical statement. Which one of the above are logical statements that we see here? So question is given, such type of questions are asked. Which of the sentences are statements? So in the first part, we want to decide which sentences are statements, means they are the logical statements. And if they are logical statements, we want to write their truth values in terms of T or F. So these are the truth values. Notations in terms of T and F are given. So for this question, some examples are given here. So we consider the first example. 6 into 4 is equal to 25. So how can you decide according to our previous knowledge? 6 into 4, that is 25, is equal to 24 is equal to 25. So it is a wrong statement, but we can say that it is a logical statement as it is a wrong, and as it is not true, but it is a logical statement and it has truth value as not logical. We can write it not logical. Sorry, it is logical and truth value is F. Truth value is F. Truth value F. Next example, x plus 6 is equal to 9. So here for what value of x, so equation is satisfied, that we can't say here. Means we can take any value of x, that is the real number, and for which this equation to be satisfied, but that we don't know. Means for all values of x, this equation is open, and therefore we can say that it is a open sentence, and not truth value. It has no truth value. So this is to be remembered. Any open sentences has not truth value there. Then third problem is that third example, what are you doing? So here question mark is given, and it is very easy. It is a interrogative sentence, and interrogative sentence we have already written there. It is not a logical statement, so it is not logical, and no question of the truth value assigned it. So this is to be remembered here, as we have given above. Interrogative, exclamatory, imperative, open sentences are not logical statements, and therefore they have no truth values. That is to be remembered. Then we come to the fourth example. The quadratic equation x square minus 5x plus 6 is equal to 0 has two real roots. So it is a statement, it is a logical statement, and its truth value is t. So it is logical statement, I write in short LS, logical statement, and truth value is t. But sometimes the x square minus 5x plus 6 is equal to 0 this much part is given in our problem and this condition has two real roots, this condition is not given, so then our solution will be changed. We can't like this, it is a logical statement and its truth value is t. So we don't know x square minus 5x plus 6 is equal to 0. For what value of x this equation is to be satisfied, that is we don't know, we are uncertain, and therefore at that time we can say that it is a open sentence, but here as the condition is given, therefore it is a logical statement and its truth value is t. Then example number 5, please sit down. Please sit down, this is the request, means it comes under the imperative sentence that we have already written above, which is not a logical statement. So it is an imperative sentence which is not a logical statement. So not logical statement. It is not logical statement. As it is not logical statement, again it has no truth value. Then we come to the 6. Every real number is a complex number. So every real number is a complex number. It is a logical statement. It is logical statement and its truth value is t. Truth value is t. So this is about the logical statement. Now next example. The square of a prime number is a prime number. So square of a prime number is a prime number as it is a logical statement. It is a logical statement. Logical statement. But it is not necessary that the square of the prime number is a prime number and therefore its truth value is false. Truth value is false. So this is about the examples on the statement which of the above are the statements and having their respective truth values. Then we come to the next part of this, which is again very important for the further study. So what are the logical connectives? What is meant by logical connectives? So that we see here. So in our language, different types of words or phrases are used, like and, or, if then, if and only if, but. So such type of words or phrases are used in our language, and these words are used to connect the two or more statements, and therefore the words are used to connect the two statements or more statements, therefore they are called as logical connectives. Logical connectives. So these are the very important words. So these words are given and, or, if then, if and only if not. So these words are called logical connectives that are used to connect two or more logical statements. So first of all, we see about the logical connective, and the logical connective that is used in different statements. So here the first logical connective and so used in the statement, so that is conjunction statement. That statement is called a conjunction statement. So we say that two statements connected by and called as conjunction statement, and symbolic notation for this P and Q, where P is the statement, Q is the statement, they are connected by and therefore read as P and Q. So we see the truth table for it. We see the truth table for it in the simple way. We use the truth table for it. So truth table for the conjunction that we see here. Truth table. or conjunction statement, conjunction statement, that is P and Q, P and Q. So here, what is the rule? Conjunction rule statement. So this is the P, Q. These are the prime statements, and the conjunction means and. Two statements P and Q are connected by the connective and therefore this statement P and Q is called the conjunction statement. Now we take the different truth values TT, TF, FT, FF. So these are the truth values related to the statements P and Q. So here, what is the rule for this? P and Q is true. P and Q is true. So that rule we want to find out here. So for truth values, P is true, Q is true, then P and Q is true. P and Q is true. That is the conjunction statement is true, and otherwise it is false. It is false. It is false. So this is the truth table for the conjunction statement. So how can you remember this? If P is true, Q is true, then P and Q is true, otherwise it is false. For remaining truth values, P is true, Q is false, P and Q is false, P is false, Q is true, P and Q is false, P is false, Q is false, P and Q is false. So this is the meaning or the rule for the conjunction statement. As both the statements P and Q are true, then the conjunction statement is true. So this is the simple rule. If both P and Q are true, then conjunction statement P and Q is true. So this is the rule for conjunction statements. So you have to only remember that if both the statements are true, then the conjunction statement is true. Otherwise, it is false. Otherwise, it is false. So we stop here, and then the next lecture we start with the